So now that you have a basic idea of what makes a set of numbers a function or not, we are going to take a look at a few different illustrations of sets of numbers, of relations, and you will find new ways to determine whether the way that they're illustrated shows a function or not a function. You'll definitely want to label your notes function or not. Okay, let's take a look at our standards. We are in the middle of 8F1, understanding that a function is a rule that assigns to each input exactly one output. So we're going to make sense of problems, persevere to solve them, construct viable arguments, critique the reasoning of others, and model with mathematics. Oops, sorry. How can I determine if a relation is a function? So that's our main question today. Yesterday you looked at, or the last activity you looked at some functions or some relations to determine whether they were a function or not. We're going to look at some different types of relations as well. Okay, so a little review. If you do not have this word in your vocabulary list, make sure you add this vocabulary word. Function, a relation where each member of the domain, which is also known as the input or the x value, is paired with exactly one member of the range, or the output or y value. So each input has its own output. Okay, so our first example is going to be mapping. So for each of these examples, you're going to need to write down what it's called, and I'm going to actually add the word diagram. So our first is a mapping diagram. A mapping diagram says that each domain or input is paired with one range or output. Okay, and that's been happening all along. Each domain needs to be unique, and it's paired with one range. Okay, so one domain matches with one range. A different domain can match with that same range, but each domain needs its own range. Okay, so make sure you copy the definition down, and then copy the mapping activity down. So push pause until you get that all done. What we're looking at here is, again, each domain pairs with a range. Okay, each domain pairs with one range. If you were to write these as ordered pairs, you would have 19 matches with 19, 17 matches with 12, and negative 11 matches with 7. If you were to write these out in a list, my domains would be 19, 17, negative 11. My ranges would be 12, 7, and 19. And what you want to look for is that there are no repeating domains. So none of my domains repeat, none of my domains repeat, none of my domains repeat. They're all unique. Now, let's say if 19 mapped to two numbers, 19 would be written twice in my list. 19 would be written twice in my ordered pair. Okay. But it's not. So we'll erase these. Oops, that's not an eraser. Okay. Oops. Sorry guys, don't copy this blue stuff down. Okay, it won't let me erase it. So don't copy the blue. Okay, so this mapping diagram is showing that yes, it is a function, because all domain values are unique. Okay, so let's look at another mapping diagram. So label this example 2. And I want you to copy this mapping diagram down, and then I want you to list the ordered pairs that you see mapped here. So hit pause, copy this table down, and then write down the ordered pairs that you see mapped. Okay, so check your ordered pairs compared to mine. And I want you to take a look at our domains. Do we have any numbers repeating? So do any of my domains repeat? Hopefully you notice this. I have a repeating domain. So no, this is not a function. So you would say no, you could, there's a couple different ways you could say this. You could say each domain is not unique, or you have a repeated number in the domain. However you'd like to say it. So it is not a function because we have a number repeating. This 6 right here, the fact that it's going to 2 different ranges is a problem. That's our issue. So however you want to label this, that we have a problem here, definitely label that. Okay, our next type of illustration is a table. Each x is paired with one y. Okay, so copy down the words up top, copy down this table, and I want you to take a look at, is each x paired with one y? Do we have unique domain values? And I want you to determine, is this a function or not? Hopefully you saw that each x value is unique. So, yes, this relation is a function because each of those x values are unique. Oops. Sorry about this. Okay, there we go. So here's our example number 2 for tables. So I want you to take a look at this table, copy it down, hit pause, and determine whether this is going to be a function or not, and think about why that is. Okay, so the first thing is going to be copying. If you need to take a look and rewrite them as ordered pairs, you can. Okay, with a table, it's actually pretty simple to see our ordered pairs. And what you should notice is I have a number repeating in my x values. So not unique x values, not a function. So you're probably noticing in the domain we have some, or excuse me, in the range we have some repeated numbers. That's okay. You can have as many repeated numbers in the range or the y values as you want. The x values must be unique. You cannot have any repeating x values. So that's what we want to focus on, are the x values. Okay, next situation, just a list of ordered pairs, which actually is very simple because it's just like our mapping on the first one and just like our table on the last one. It's just the numbers are written in ordered pairs straight out instead of any other way. All right, so take a look. Make sure you copy down the word ordered pairs and that each x is paired with one y. Copy down your ordered pairs and let's take a look. So hit pause so that we can get back and take a look at this. Right, for my ordered pairs, we're focusing on our x values. Are they unique? Yes, I don't have any repeating x values. So yes, this is a function. All x values are unique. For each x, there is a y. Okay, so take a look at this as example number 2. Copy down these ordered pairs and determine if there's a function or not, and tell me why. Okay, hopefully you saw that there were 8 is repeated. Domain values are not unique. So the answer is no. All right, last illustration. This is one you have not seen yet. Our last illustration is with a graph. Now up to this point you saw the ordered pairs basically laid out in numbers. Now we're going to take a look at a graph. So copy the word graph down. Each x coordinate is paired with one y coordinate. Now when you're looking at a graph, you could go ahead and rewrite each of your ordered pairs if you'd like. So we have -5, -2, -3, -2, we have -2, 0, and I have 2, -1. So you could list out your ordered pairs, and you could look for unique x values. And if you notice here, we do have unique x values. So yes, this is going to be a function. However, with a graph, writing the ordered pairs takes so much time. It's ridiculous. So there is something that you can do, a little test that will help you determine if it's a function or not. And it's called the vertical line test. Okay, so what I want you to do is make sure you copy down this vertical line test. Okay, so make a note that says vertical line test. Here's what the test says. It says draw a vertical line anywhere. It should never cross twice. Okay, so for the vertical line test, the official definition says if you can draw a vertical line so that it hits the graph in more than one spot, it is not a function. Okay, so let's take a look. So what I want to do is anytime I see a point, if I draw a vertical line through it, it should only hit, if it hits more than one point, it is not a function. So if I draw a line through each of these points and there are no other points it hits, then yes, it is a function. Here's what that means. If I had another point here, if we looked at the ordered pairs of these 2 points right here, my ordered pairs would be -2, 0, and -2, 2. Do you see how my x coordinates are not unique? Because my domain numbers are not unique, this would not be a function. So according to what we've already known, this would not be a function. Now this test actually does that work for us. It does the work of finding duplicate x values. If I have two points along the same line, and it's a vertical line, that means they have a common x value. Okay, so that's why that vertical line test works. So pause, make sure you get that copied down, and let's take a look at one more example. Okay, so if we look at this graph, I want you to make sure you get this copied down. So we're going to say example 2, copy this graph down. And go ahead and pause while you do that. And let's take a look. Every time I see a point, if I draw a vertical line, do you see how right here crosses more than one? So crosses multiple x values. So fails the vertical line test. So no, it is not a function. It does not have unique x values. It fails the vertical line test. This works for anything. Okay, so pause. I'm going to erase it. I'm going to show you a third example that I want you to copy. Okay, so we're going to call this example 3. So for example 3, draw a coordinate plane, and I just want you to draw a line like this. Let me try that again. Okay, if you drew a line like this, and we did the vertical line test on it, basically what you're doing is you're just going to draw vertical lines, and do this enough and you can visualize it. If I drew enough vertical lines, do you see how it only touches the line at one point? So that would make that a function. Yes, that's a function. Okay, I'm going to show you a couple more, but you do not need to copy them. Just watch. Oops, I covered up my mess here. Okay, so ignore those. Let's take a look at another one. If you had something like this as your graph, again, I could do the vertical line test. Go through, it only crosses one, so yes, that would be a function. Okay, if we looked at another, okay, if I had something that looked like this as a graph, if we did the vertical line test, the minute I draw a vertical line anywhere and it crosses 2 points, no, that would not be a function. It fails the vertical line test. So if you'd like to add a couple more examples, you can. Ultimately, if all else fails and you have a graph and you're not sure what to do, find a couple ordered pairs. You're focusing in on repeated x values. So if you notice that if you grab a couple ordered pairs, don't try to find some that are unique. Look at that graph and see, is there any point where I'm going to have a duplicate x value? And that tells you it's not a function. Okay, so, oops. Let's do a little review of our vocabulary. Make sure that you have these 3 words in your vocabulary list. The mapping diagram, you'll have to go back to the example. The mapping example was the first example, and copy down the description of the mapping diagram. For the vertical line test, that's written on the last page, or one of the last pages as well. Okay, so now it's your turn. You have an activity to complete next. The video's over. Ask questions if you have any left. Okay, so our first example is going to be mapping. So for each of these examples, you're going to need to write down what it's called, and I'm going to actually add the word diagram. So our first is a mapping diagram. A mapping diagram says that each domain or input is paired with one range or output. Okay, and that's been happening all along. Each domain needs to be unique, and it's paired with one range. Okay, so one domain matches with one range. A different domain can match with that same range, but each domain needs its own range. Okay, so make sure you copy the definition down, and then copy the mapping activity down. So push pause until you get that all done. What we're looking at here is, again, each domain pairs with a range. Okay, each domain pairs with one range. If you were to write these as ordered pairs, you would have 19 matches with 19, 17 matches with 12, and negative 11 matches with 7. If you were to write these out in a list, my domains would be 19, 17, negative 11. My ranges would be 12, 7, and 19. And what you want to look for is that there are no repeating domains. So none of my domains repeat, none of my domains repeat, none of my domains repeat. They're all unique. Now, let's say if 19 mapped to 2 numbers, 19 would be written twice in my list. 19 would be written twice in my ordered pair. Okay. But it's not. So we'll erase these. Oops, that's not an eraser. Okay. Oops. Sorry guys, don't copy this blue stuff down. Okay, it won't let me erase it. So don't copy the blue. Okay, so this mapping diagram is showing that yes, it is a function, because all domain values are unique.